So once again, good day everyone. We are meant to continue from where we stopped on Tuesday. Um, for those that are not yet here, you can just send a message to your friends or colleague that you know is meant to be in the class that is not here right now, and help them remember that the class has started. So I'll be sending this to the um, Discord channel now, just as a reminder that the class has started. Okay. Okay, so we would proceed, and then other people can troop in and gradually join us. So as usual, today we are meant to complete this slide, understanding the Stellar Consensus Protocol. And we've discussed so much from this slide that we now have basic understanding of so many things when it comes to Stellar Consensus Protocol. Okay, so this is literally where we are meant to continue from, and what we discussed last basically was ledgers in SCP. So as usual, you know how we do it. We start by asking ourselves questions based on what we have discussed from our last class, and also those who have questions would basically ask their questions so they can, dovetail the knowledge they've got from previous class into the one we would be having in today's class. So I mentioned on Tuesday that I would start with asking Beulah to explain what the consensus protocol was after the question she asked me, and I explained it to her. So I think I should start from there. So it's more like also going to be an opportunity to give an overview of what we have discussed. So Beulah, you can unmute your mic and give us explanation on what we discussed last time when it comes to explaining what a quorum is, the quorum slice, and how it affects the consensus mechanism. So let's hear from you, please. Oh, sorry.
Good evening, everyone.
Good evening.
Good evening. Okay. So last time we talked about ledger. We talked about how the previous hash we talked about ledger. Then you showed us hash, like the previous hash, how the previous address get to work on like get to appear on each ledger, and before the ledger contains informations that, like, transaction time, process, like, of that particular transaction. It contains several information. Then it has to be, for it to be added to the blockchain, it has to align with, it has to have a previous action. Is it not previous action, but see, like, it has to have this like the previous block, it has to have the address or something, and you showed us that it's similar to each other. And then concerning the consensus, um you said that you said that it, so we have proof of work, we have proof of stake, then we have this FD, forgotten the name actually, what is that from F, then
Executed Valentine Agreement.
yes sir. Then you tried explaining how that works also, and how it's different from the proof of work and the proof of stake, sir. Basically, that's what we did, sir.
Thank you. Thank you very much. So you've basically given us like an update on some of the things that has to do with the consensus mechanism, but you did not touch about quorum, threshold, quorum slice, blocking set, and all of that. Is there someone from the audience that would like to talk about that, just as a means to remind ourselves? Shaliga, can you hear me, Shaliga? Hello, can everyone hear me?
Yes, we can hear you.
Okay, okay, okay. How come Shaliga is not unmuting his mic at all? Is it not with his device? Okay, so without wasting our time, will someone else want to talk about what a blocking set is, and what voting has to do with quorum and quorum slice? Will anyone want to remind us or something? Yeah, Edwin, please.
Yes, good evening, everyone. Thank you, Ayo. So I'll start with the quorum. So the quorum is like a set of nodes that are sufficient for a node to reach an agreement. I don't know whether that's right. So for a quorum slice, it's like the number of trusted nodes a node can pick for a transaction to happen. Then what was the other? What was the other?
Blocking
Blocking
set.
set. Blocking sets are the nodes that could stop. Are the nodes that could stop a node from reaching the consensus.
Excellent. Thank you so much. That's literally it. Thank you so much, Adrian. Thank you so much. So, thank you so much, Adrian and Viola, for the overview on everything under the consensus mechanism that has to do with a ledger linking up with the previous ledger to form a block. Okay. So, like I made mention of today, we'll be starting from here that has to do with ledger. Our last class ended while we were trying to explain the components of the ledger, where I basically showed you what a ledger looks like through the stellar scan. And with that, we were able to see that the ledger contains components like the accounts, the balance, the order, and even smart contract details that has to do with, calling a smart contract, interacting with a smart contract. So all of these are basically things you would see inside of a ledger. And we literally saw it when I showed the scan. Now, I went on to talk about the ledger chain and how it literally becomes a chain where the word blockchain literally is, where that word was coined from, is literally talking about the historical continuity of these ledgers. And these ledgers are literally continued through a cryptographic hash that links the previous one to the next one. And from what Beulah made mention of, she spoke about it, that each of the new ledgers contains the hash of the previous ledger. And this leads to a situation whereby the chain, the ledger, is immutable. And this literally ensures integrity and continuity of the transaction history. So I was the one asking question. Before I proceed, is there anyone that would want to ask any question again? Then we can answer those questions and proceed from there. Anyone? Anyone? Okay. I'll take the silence as everyone truly understanding everything. Ledger entries. There are different types of ledger entries. We have accounts, we have claimable balance, we have liquidity pools, we have contract data. What are accounts? Accounts basically hold balance and they are used to sign transactions. So you can think of account as your wallet. An account literally have the private key and the public key. And this is literally what you use to sign a transaction. The transaction could be either you sending a write call to a contract, or you trying to send probably a native token, in this case, Lumen, from one account to another account. It's literally the key. It's literally the key to you mutating or for you to add transactions to the blockchain. So your account, you can just think of it as a wallet, because a wallet is literally what holds your account. And it includes both your private key and your public keys. We have claimable balance. These are unclaimed transaction amounts that can be claimed by specific accounts. So there are some transactions with unclaimed amounts, and these transactions can, the money can be claimed. Okay, this situation can come in different form actually. A situation whereby there are balances that should be claimed, and this transaction, some transaction owes this particular how do I put it? Some transaction owe this particular amount. Okay, I'll give an example of a situation that you could think of when it comes to claimable accounts and claimable amounts anyways. So let's use the example of a multi-sig for an instance. In a case whereby you have a multi-signature account, what do I mean by multi-sig for those that have zero knowledge on what a multi-sig is? A multi-sig is basically an account that ensures, I think I've explained what multi-sig is before, but I'll explain it again. It's an account that includes having more than one person to sign a transaction, and if the total threshold, that is the threshold needed to sign that transaction, is 8, then the transaction would be sent. So just to make it clear, I am going to draw something. I'll stop presenting. Give me a second. I'm going to draw something on the screen to literally explain what a multi-sig is. So give me a second, please. So I literally went to take my phone so I could literally share my screen to show what a multi-signature. I'm going to draw it to explain what a multi-sig is all about. Give me a second. I noticed it's mentioning that the phone has been updated. Okay. This is really giving me a tough time. I'm so sorry about that. Okay. Okay, since it's not allowing me to use it at the moment, I'll just continue explaining what I want to explain. But let me look for something else to use. So I'm going to use skledraw to explain this. So, okay. So let me share my screen. And so, can I get a thumbs up to show that everyone can see my screen? Okay, sure, good. Now I'm going to explain what a multi-sig is. Now imagine we have this smart contract, and then in this smart contract we have about, let's say we have about $10,000 in this smart account. We have about $10,000 here. Now, inside of this smart account, we are inside of this smart contract, let's say we have about 5 people that are signatory account to this smart account, to this smart contract. We have, let's say, user 1, user 2, user 3, user 4, then we say user 5. Okay. So now, in this particular case, I'll use this as an example of a multisig. Now, a multisig is a situation whereby you have a total amount of users that can sign an account, but then you have what we call a threshold. So let's say for this particular account, the threshold for this account is 3. So that means that threshold for, let me delete this. I don't think I need that. Let's say the threshold for this account is 3. So that means that we need just 1, 2, 3 to send the transaction. So that means user 1, user 2, user 3 can send the transaction, and then the transaction would be sent. So let's say they want to send $50 out of this $100. User 1 will sign the transaction. The money would have not sent. User 2 have to sign. If someone saying, oh, the font size is too small, okay, let me increase it. How about now? Is this better? Okay. So for the multisig, user 1 has to sign, user 2 has to sign, then user 3. In another case, it could be user 4, user 5, or user 2 that will sign the account. Now, notice where we are getting out as an example of what we are talking about on claim balances. In this particular case, user 1 and user 2, imagine they have signed. At that particular time, they want to send money to probably user 5. They want to send money to user 5. Now, if user 1 and 2 have signed this transaction and no one has signed apart from user 1 and 2, at that particular point, the money would not leave this account, this smart contract, until the last person signs. That is when the money would then go to whoever the money is being sent to. That's literally the example of multisig. You understand? So in a multisig, you can have different amounts of threshold. You can have that is just 2 people you need to sign its signature, as long as 1, 2 have signed, or 1, 3 have signed, or 1, 4, or any combination of 2 people from this multi-signature account have signed, then the transaction will be sent. But in the situation whereby this transaction has not been completely signed, then the money have not moved to that person. So it's more like an unclaimed balance. So that's more like a simple explanation to explain what we are trying to get at. So I'll start sharing my slide back and we can proceed. Beulah?
Yes, I quickly want to ask, is it their address that they used to sign, or what do they use to sign?
You use your private key to sign. So to sign a transaction, you use your private key. Your public address is generated from your private key through different chains use different kinds of wallets. Now, for EVM, your private key goes through some kind of checksum, and then when it is verify that, okay, this private key has not been used and all of that, then it's used what we call an elliptic curve to generate the public key from the private key. As time goes on, if you are willing to also gain more knowledge, not just on Stellar, you want to get more knowledge on the EVM, you start learning things like EDCSA for talking about elliptic curves to generate public key from private keys. So that's more like it. Now, another one is liquidity pools. This facilitates decentralized trading by allowing users to pool assets and trade against the pool. Now, I don't know if there's anybody on this call that have experienced trading before. You know, now when we are saying trading, it has nothing to do with writing of code, just trading of cryptocurrencies. Now, this is where liquidity pool comes in, and I'm going to also stop sharing and share my screen to explain what a liquidity pool truly looks like. So give me a second. Let me see if this is even up. Okay, still not up. Sometimes the device could be funny. So let me still use my system and use Escalate Draw to explain this. So this is what the liquidity pool looks like. Inside of a liquidity pool, let's say this is the pool. You will have token A, and then you will have token B inside of the liquidity pool. Now, I'm not going to use this opportunity to explain what automatic market maker is, but I'm just going to give you an overview of what a liquidity pool looks like. So inside of the pool, let's say you have token A, then you have token B. Token B. So now, for this token A and token B, two of them are two tokens inside of this pool. And this pool is more like a smart contract. So when token A and token B is being sent, if you as a person, you come in, let's say token A is USDC and token B is a different token. Let's say you want to buy token A, which is USDC, and you want to sell your other token. Let's say, for example, let's use Lumen, for example. Let's say token B is Lumen. In this particular case, based on the amount of tokens that is there, if the one you want to sell is being sent here, this one increases, and then this one decreases in the pool, and that affects the price of this one, basically. And that's exactly how liquidity pool works, whereby a contract where we have two tokens, token A and token B, and you take out from this, then you send into this. For the automated market maker, it just use a simple formula, K equals X over Y, or Y over X, I mean. And then with that, you talk about pool, basically. But there's so much more to it than I've just explained. I just gave a simple brief on what a pool looks like and how it affects, you know, tokens trading. And as an individual, this could be part of what you would want to do when you start writing your Sovereign smart contract. I mean, you could decide to create a pool, what do I call it? A liquidity pool where people could literally trade tokens and assets against each other. So that's just like an overview of what it is. So that could also be inside of the ledger entry. Another one is the contract data. So now, at the end of the day, when you finish writing your smart contract, this smart contract actually have data. And this data is literally what you are interacting with. At the end of the day, when we start writing the Soroban smart contract, we see how we first compile the smart contract, and then we deploy the WASM file of that smart contract to the ledger. And this WASM file is basically what we would use to interact with the smart contract. So all the implementations that are inside of the WASM file would basically be what we would be using to interact with the smart contract functionality. And that's basically it. So the contract data could include the storage and the functionality. When I say functionalities, it includes all the functions involved inside of the smart contract. All of these would literally come together to form as the contract data. So we've literally spoken about the entries when it comes to the ledger. Another one is the ledger header. What is the ledger header? The ledger header contains key details about the ledger, such as the sequence number, the hash of the previous ledger, and the total number of transactions included in the ledger. I'm sure I've shown you what I'm about to show you again, but I'm going to show it just to refresh our memory on what this literally is when we are talking about the ledger header. So I'm going to show us the scan again, and I'm going to share my screen for that again. So I'm going to just pick up just one, and can we see what the ledger header looks like? It includes the ledger sequence number, the ledger current hash, the previous hash, when this transaction was added, and on and on and on like that. That's literally what the ledger header looks like. And from last class, I was able to show you all of these. So let's go back to our slide. Accounts. Accounts are the central data structure for holding balances, signing transactions, and issuing assets. Each account is identified by a unique key pair. Can someone explain to me why it is important that an account include both the private key and the public key? Anyone willing to just try to explain why an account includes both the private key and the public key?
Thank you. So I think the reason as why an account needs a public key and a private key is because the private key is for like privacy and encryption. So the public key is what the other users on the blockchain must see. Then the private key is your key that you use for, I think, accessing. I'm not so sure about the hashing thing, but I would say that it's your key for like privacy to access your data or your coins. I don't know, something like that.
You've done well. You've done very well. You've done very well. Done very well. Thank you. Can someone else also add, or anyone have something else to say about that? Okay, divine.
Okay, from my own understanding, I feel it has a public key because that's I think like your address that will be used to send transactions to you. Why the private key is used for signing those transactions, which is not supposed to be seen by others. So the private key is private to you, while the public key is public. You can use it to access transactions.
Excellent answer. Excellent answer. In fact, that is 100%. Thank you so much, Edrin and Divine. Thank you so much. You guys did a great job at explaining what an account is, basically. So let's say I want to send you some lumens. No, why should I send you some lumens? Let's say you want to send me some lumens. In that case, you will not ask me to send you my private key. Rather, you will ask me to send you my public key. So that public key is literally what you asked me to send so that you can send the lumens to me. Because if I send you my private key at that particular point, you have access to all my assets and you can sign any transaction on my behalf. So this is just a simple warning as blockchain developers, because as time goes on, you will start writing, and some of what you would be needing to sign or send your transaction would be your private keys. And in our case, as okay, you have a question, okay?
Sorry to disturb you while you're busy with the lecture. Quick question. I'm just curious because you're talking about the keys. I'd really like to know what would happen if, for some strange reason, you were to lose your keys. Is it possible for the system to generate another key which still is linked to your account? Or what happens in those kind of situations or scenarios?
You see, that's a very beautiful question. And you know why I'm laughing? I'm laughing because this is one of I should like say the problem when it comes to the blockchain. Now, when you talk about a traditional finance, when you forget the password or the keychain to log into your account for your bank, your password basically to log into your account for your bank. If you've forgotten about it, it's so simple for you to go to the bank and tell them, oh, I've forgotten the password to my account. And basically the bank would verify you are the owner of the account through your picture, your signature, and all of that. And then they basically help you generate new passwords. It's so simple like that. But now, when talking about the blockchain, remember that the blockchain is a decentralized system where no one has a control over it. So that means if you lose your private keys to your account, it automatically means you've lost your asset on that wallet. There is no way for you to recover it at all.
What? Wait. Whoa. So if what you're saying to me, I've got millions and millions or
Yes.
billions of rands in that account. If I lose the key, I've lost all the assets that are there.
Actually, that's very correct.
Yo!
You see, some times ago, there were some people who had bought, Bitcoin at the early stage. And, at the early stage, Bitcoin had very low price. I mean, some people were exchanging it with, pizza and all of that. That was how little the value of it was. But then they did not take care of their private keys. They just bought the Bitcoins in the wallet and they lost access to the private key. And eventually when Bitcoin boomed up and it started selling for tens of thousands of dollars, they started looking for the private key. Some could not recover it and they basically lost access to the asset. So that's basically it. One important thing when you are creating a wallet every time is you are always told to write your private key down using pencil, biro and paper, I mean. You are always told to write your private key down using biro and paper. Sometimes it's usually, you are told to use to save your seed phrase, since that is usually more easy. Although there are now devices you can basically store your private keys so that at the end of the day, you keep it safe somewhere. This is also another reason why some people prefer using centralized exchanges. Centralized exchanges basically would not give you your private key. Rather, they would keep the private key and they would rather give you a password. So they'll basically be the one controlling your assets. So you send money to that wallet. If you've forgotten your password to the centralized exchange, all you have to do is to do forget password, and you generate a new password, verify it's you, and all of that. It's that simple. But at the end of the day, it's still thinking that, okay, this asset is literally not in my hand. I mean, there are still some set of people that are controlling this asset. Can I call that completely decentralized? That's why it's called centralized exchanges. So it's important as blockchain developers that you keep your wallet safe. Another thing I want to say again is this, what I'm about to say now is, as a blockchain developer, it has happened to me so very well, because as time goes on, there might be no opportunities for me to even talk about what I'm about to say again as we proceed. So I'll just use this as an opportunity to talk about it. There are people that are scammers, basically, and they are always looking to exploit blockchain developers. And that's why, as you proceed in learning, you know, they know that you basically would deal with private keys storage. Some will store their private key as inside a notebook or inside a document in their laptop and all of that. So it's important as a blockchain developer that you are always safe. What do I mean by this? As time goes on, when you update your LinkedIn, your other socials as blockchain developers, you tend to see scams, dubious individuals that would message you on LinkedIn and tell you they have jobs for you, and then they would tell you to run some code, and this code would include malicious payload. And once this payload are being loaded on your computer, it creates a backdoor for them to have access to all of your private keys. So it's important that you are careful as to what you run when it comes. They could pretend to be recruiters and say they are trying to recruit blockchain developers and they want to give you a test. And if you pass the test, they would give you the job, on and on and on like that. It's important that you are careful about this. That, in fact, if you want to go ahead to, you know, run some of these tests and all of that, you try to run it in a sandboxed environment that has nothing to do with your local environment. So they don't have access to your local computer, because most of these scammers and dubious individuals target a whole lot of blockchain developers. And unfortunately, some of my colleagues are falling for this, and they've lost thousands of dollars worth of assets based on this situation. So it's important that you are careful keeping your own private key for yourself, and, you know, also trying to guide against others stealing it from you. So that's basically that on private keys and accounts. Creation. To create an account, a valid key pair and a minimum balance of lumens are required. The minimum balance prevents spam accounts and ensures network integrity. So that's what you need to create a key pair. So components, we spoke about account ID, balances, flags, home domain, liabilities, sequence number, signers, thresholds. Let's start from the first one, account ID. The unique identifier for the account derived from the public key. So here is actually the truth about it. Sometimes we mix it up, and I'm sure while I was speaking earlier, I've probably mixed it up and not specifically pulled that out. Now, there's actually difference between a public key and a public address. There's actually difference between these two. I probably have mistaken it while I was talking earlier. A public address is what you send. And when you generate your wallet, what you see is actually your public, your private key and your public address. Your public key is actually where your public address is generated from. And now, your public address can also be called your account ID. It's actually unique. Remember, I was saying that it goes through what we call checksum before it is being created. So when your wallet is created, it ensures that it has not been created before. So you don't automatically wake up one morning, create a wallet, and be like, oh my God, I now have access to someone else's private key. Imagine it was the same private key with someone else that has generated before, and there are some assets there. So it goes through checksum and it is unique from every other person's own. It's just like your bank account. Your bank account, the bank number, the account number is definitely different from another person's bank number. So it's important that it's like that, so someone doesn't send asset to you that is meant to go to someone else, or the one that is meant to go to you goes to someone else. So that's about the account ID, which is generated from the public key. Then we have what we call balances. The account holding of various assets, including lumens and other issued assets. So the balances is where you find the lumen, and these balances is actually embedded inside of the Stellar Core itself. What do I mean by this? While your account is what have access to your balances, you have to understand that the balance of your lumen is completely different from the balance of your normal smart contract token. Why? This is because your lumen is a native token, and that balance is literally embedded in the Stellar Core itself. And that's where you find the balance of an account. So when you say that you are sending lumen from point A to point B, you're not talking about smart contract interaction. But when you say you are sending USDC on Stellar from point A to point B, you are actually talking about smart contract interaction, because it's basically smart contract. You are yourself, you can wake up one day, create your own token. It's just a smart contract and you deploy it. But the lumen is basically incorporated inside of the Stellar Core. And this is basically where the balance lives, the balance to each account. We have flags, settings that control account behavior, such as authorization flags for issuing assets. Yes, we have home domain, a metadata field that links the account to a web domain, useful for identifying the account owners. So there are accounts whereby you have a situation whereby some individuals have created more like a domain that is attached to a public address. And that public address, instead of you having to type out the public address to send tokens or to interact with that address, you can just use the domain, because the domain is linked to this address. And you can hear some people talk about their public key and say, no, instead of sending to when you ask them, when they tell you, you ask them, I'm sure you can hear me now. Can you?
Yeah.
Okay, sorry. Okay, so let's continue the class basically. So I was talking about the domains whereby some people, instead of you having to send to their normal public address, they'll just link it. They buy domains and connect these domains to their public address. So when you send tokens or whatever to that domain, it basically you can use the domain that they've bought. And I was giving an example. You hear people say their domain is this.it, user.e, and on and on and on and on like that. So instead of using, so it's easy for you to basically give someone that domain and they can send you assets into it just like that. You have liabilities. What are liabilities? These accounts pending obligations such as outstanding offers in the order book. Now, all of these things you're seeing here are quite high because when we are talking about order book, then we are talking about trading. We are talking about exchange of assets. Now, while I was explaining liquidity in a pool, that is one type of decentralized trading. Another one could be order book. Order book is just like explaining order book. Let me explain it to you. So here is how order book works. So we have a list of buyers and a list of sellers. So for the sellers, they place their order and say, okay, they place what we call market order, and they say, okay, when the price of this token is so, 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 and so, I want to sell. So now buyers place their own orders, and basically when someone sees a token and the token is selling at that price the seller wishes to sell, it automatically executes the order and the token is being exchanged at that point. So there could be so many orders down, and then people that are buying and selling, the market is being executed based on how much they want to buy the asset at that particular time. That's literally what order books look like. Sequence number, it's a counter that tracks the number of transactions submitted by the account, ensuring transaction uniqueness. When we talk about this, we are talking about nonce. So the sequence number is literally the nonce, whereby, let's say you sent a transaction and then the transaction has not been added to the block. Remember from our previous class, we explained that before a transaction is added to the block, it has to go through some situations. And that situation we were talking about includes the quorum, slides, agreeing, and all of that. Now, while all of that is going on, it is possible to send another transaction before the first initial transaction is added to the block, or before the initial transaction is added to the ledger. Now, in that case, it is possible. Now, let me give you an instance. This is actually, it could come as an interview question, probably when you are trying to get a job. It's called, in that situation, it's what we call a replay attack. It's possible for you to send transaction 1, and then it's possible to send transaction 2. Why the miners, the validators have not picked transaction 1, transaction 2 would be sent. Now, what is stopping the miners from picking transaction 2 before picking transaction 1? This is as a result of what we call the sequence number, the nonce. Thanks to this nonce, it is impossible for you to replay a transaction that should have been added to the block, causing what we call an exploit. Now, what I'm saying could seem a little technical, but it's no problem. As time goes on, you begin to understand more. It's just like when we started talking about consensus from the first class, and now I'm sure everyone on this call have a complete understanding of what consensus is. So what I'm trying to talk about, as time goes on, I will talk more about it and you'll get more understanding. But I want you to understand that, imagine we have inside of a wallet, we have $100 there. a smart contract. Now you sent that this smart contract should go to what do they call it? You send it to go to person B, or in fact, let's use a name. Let's say you send this smart contract to send $100 to move into Silvano's account. Now, the miners have not yet picked up that transaction. Since they have not picked up that transaction, it means that the smart contract have not been updated. Now, it is possible for you to resend that transaction again. Now, when you resend that transaction again, if not for the sequence number, which is the nonce, it is possible to now send 2 transactions at the same time, and then for the other one to be picked as a priority before the first one. And when the other one has been picked, that means the first one also has to be picked. And in that case, you create what we call double spending. It's actually an attack when it comes to smart contracts. But then this is prevented thanks to what we call the sequence number, the nonce, basically. So that's it. Now, moving on to signers. I've made mention, signers are it's literally your account. It's literally what you use to sign a transaction. It could be sending of lumens, or even interacting with already deployed smart contract, or even deploying a smart contract. This you literally do using a signature, and this signature could be, it's literally your private key to send the attack. Now it says additional public key authorized to sign transaction on behalf of the account, enabling multi-signature functionality. I'm sure I've explained what this multi-signature is. That's another, method to sign an account. And trust me, a lot of organization makes use of multi-signature accounts. And in fact, you'll be interested to know that even the Stellar Foundation team, a lot of them make use of the multi-signature account. It's a situation whereby just one person cannot send out money anyhow. At least a total amount of people can control that wallet together. So if I sign the transaction, if I'm a signatory to the transaction, you can think of it as a joint account, basically in the normal financial world. A joint account whereby just one person cannot come and say, you want to transfer money out of this account. At least a total amount of people is needed to sign that account, and that amount of people is what we call threshold, and that's what the last one is, the minimum number of signatures required for different operations. So that threshold is the total amount of number of people, of signatures, of signers needed to sign that transaction for the transaction to move. And so that leads us to the next part, and this next part is literally trust lines. So under this, we have the opt-in mechanism and establishment. What are these? These are trust lines required for an account to hold and trade specific assets. They represent an explicit opt-in mechanism where an account must establish a trust line to an assets issuer before receiving or trading that asset. So this actually comes under the decentralized finance part of the blockchain. And this is, sorry, can you give me a second? I think I have enough. It's not in a meeting now. You kept on knocking and knocking and knocking like that. Okay, so sorry for that breaking transmission. So I was talking about the opt-in mechanism and the establishment, and I was saying this literally falls under the decentralized finance. And you really don't have to think so much about it for now. But I added it in the slide as an opportunity for you to also go back to it when you keep learning more about this smart contract and everything we are talking about, basically. So at this particular point, we have literally come to the end of this slide, basically. We've spoken about cryptocurrencies before, definitely. Talking about fiat currencies, everyone knows fiat currencies. Talking about tokens, which could be non-fungible tokens, which are NFTs, pool shares. We've spoken about all of these. And so this is literally where we come to the end of our class for today. But as usual, we definitely have questions and answers. So let me have anybody with questions and answers so we can hear your question and your answer. So we have some people. Let's start from Divine.
Okay. My question is on the creating of account. I have three questions actually. The first one
You
is
have how many
create. You said
questions?
create. Yeah,
You said you have three
I
questions.
said that. Yes, but they're very short
Okay.
questions.
Okay.
So you said to create an account, you need a minimum balance of lumens. That means if I want to generate maybe a wallet or something, I will have to have some balance in lumens. That's what I'm trying to clarify. Then the second question is the account ID, is it the same thing as wallet address? And then
Yes.
okay. And then the final question is does the Stellar network have like their own wallet that someone can use, or do we use EVM wallets?
Yes. You don't use MetaMask for Stellar. So Stellar has wallets that you can use. You don't have to use the MetaMask. I don't even think the MetaMask wallet can work for Stellar. So there are different wallets you can use when it comes to Stellar. You can use the Stellar wallet. I think you can use Exodus too. There are so many wallets you can basically use for Stellar. So many wallets. Does that answer your question?
Create an account. You said you need a minimum balance.
Yes. So how do I put that for you? To explain this better, I'm sure like hello?
You can hear you
Okay.
now.
Okay. You're probably talking perspective of Ethereum blockchain balance for you to send tokens from someone to another person when it comes to creation of the wallet. I understand that is where you are getting at. And so to start with, how do I put it for you to understand? Because I'm sure to see it as the minimum amount to create a wallet. No, don't see it like that. Don't see it like that. You can basically create a wallet. Really don't need that. You can basically create a wallet. You don't need a minimum account. Let me even see the slide. Why does the slide say? I'm trying to deal with my net.
Hi, my name. I'm also lost here. Is the lecture over? What's going on?
I think it's experiencing bad network and it dropped off.
Oh my God, I'm so sorry. The network really did me dirty this evening. And the network really did me an issue. Okay. So yeah, I'm back. I hope Shilanga is still on this call. Did you get what I was trying to explain earlier about the wallet? Hello? Hello?
Some people move.
Did you get what I was trying to explain earlier? I didn't hear him clearly. Did someone else hear him clearly? Hello?
Yes, Mr. Ayo, we can hear you now.
Okay, I was saying, did you hear what I was trying to explain earlier?
Yes, yes.
Yeah, you ended on explaining the minimum balance to activate the account. You say it's not about creating the account.
So it's not about you creating the account. You understand? It's more like still explaining to send a transaction. It's all about sending the transaction. Anybody can literally create an account. You get? Does that make sense to you? Okay. So I'll stop recording here and I'll just take the remaining questions from others. Okay.